over people. So, all right. So basically, you did a criterion B assessment, still marking it, but I want to go through hopefully what you realised. That's why all our criterion B assessments are actually going to be formative assessments, because we have to use that information to carry on. So it's not just a case of, oh, we did it, let's move on. It's a case of, did you figure out the right stuff? If you didn't, well, when we go through what you hopefully found, if you didn't think that yourself, you need to make sure you made those notes. So this assessment was about, do you understand what complementary events in probability are? Right? So by the end of what we go through, hopefully you will then realise exactly what a complementary event is, and it's not that much actually. It's not that difficult. It's not that much information to try and remember. But let's just go through a few of these answers. Right, we'll go through them quickly, and then what you're going to write in your book is the definition of a complementary event. We'll do that together. I'll go back to my first page. But verbally, tell me what the answers are. So we've got a die which has 12 sides. Got the numbers 1, 2, 3, 4, blah blah blah. Okay, what's the probability of rolling a 12? Well, there is 1/12 out of 12 options. What's the probability of rolling less than 12? 11. 12. Rolling an even number. 6 from 12, or a half. 6 from 12. Okay. This would be 1, 2, 3, 4, 5, 6, 7, 8. This people got the wrong way around actually. Rolling a number less than or equal to 3. That would be a 1, a 2, or a 3. So it's 3 from 12. This would be more than 3. So 4, 5, 6, all the way up to 12. So that would be 9 from 12. Okay? So those two probably. I haven't simplified any of them. So Larry, look like you want to be in. I know you don't, but look like you do. Sit up. Okay? Alright. Tick next. Now, some people didn't interpret that question correctly, but tick next to the event which is likely to occur. So in each test, some people just put 1 tick. But it should be out of test A, which one is the most likely? This one. That was tricky, so you can put tick or no tick. It's up to you. This one is this one. This one is this one. Some people said just column 2 is all column. Okay. Now here is where the answers we're looking for. So why criterion B can be a little tricky. So what is the relationship between the events on 1 column 2? Now, a couple of people that I've seen so far got close, not perfect. Some people just didn't spot it at all. All right. Now, what you hopefully will notice, all right. So, what is the relationship between the events, not the probability? The events are.
So, rolling 12, rolling less than 12, rolling even number, rolling the opposite. So opposite.
So one of the ones I've read, so 2 actually use the word opposite. It's not really opposite. What's the opposite of a 3? All right, not a 3. All right, that could be the opposite. Even number, odd number, potentially are opposite, but 3 or less, those lists are not opposite, are they? So the word opposite, I think I've been commenting, I understand what you mean, but the word opposite is not really appropriate. All right? Not everything has an opposite. Number 3, the only opposite to number 3 is not a number 3. All right? 5 is not opposite of 3. Does that make sense? So how can we describe this better than the word opposite? Okay. Well, events column 1 and column 2. What is the relationship? Well, not yet, because we can't use that word because we don't know what complementary means yet. The relationship is actually, okay, we could say the 2 columns show all possible outcomes for that event. Remember, we've talked using that vocabulary, haven't we? So both for the event, okay, for test A, rolling a 12, rolling less than 12, there is nothing else that could happen, is there? Rolling an even number, rolling an odd number, that's all possible outcomes, right? Nothing else can happen. So we could say nothing else can happen other than those 2 things, is another way to write it. Does that make sense?
Yeah.
Okay. Did anyone write that along those lines? Well, we'll see. What is the relationship between the probability? Well, here's the important bit actually. The probabilities, some people, because they're not writing, are not paying any attention. I'm not saying I want you to write, I told you not to write, but I did say I need you to think and focus further, right? Just stay with it. What do you notice about the probabilities of each column? Broken? Oh. No, we're in the middle, unless you're absolutely desperate. If you are, then feel free. Otherwise, you've interrupted my video. If you're desperate, get a move on. I'd rather, but if you can wait. All right, what's the probability, Alyssa? Okay, yeah, what's the relationship between the 2 probabilities? Right? Well, ideally, yeah, we could write they add up to 12 out of 12, or 1. Now I think, Chase, you wrote adds up to a whole number, which isn't the same thing as a whole. Yeah, but later on in your thing you did redeem and say 1. Right, so, but they add up to 1, right? So it's 12 out of 12 is fine, or they add up to 1, but that's the probabilities. If you add those 2 together, you know, e.g., for example, 11 out of 12 plus 1 out of 12 gives you 12 out of 12. Okay? Or we could say 100% if you like. That's what we were looking for. Make sense? Okay. Create a test where 2 of them involving a 12-sided die. Now, just note, guys, 2 events involving a 12-sided die. So that means we need to have the 2 things, 2 sides. So the probability of, I would say, I'm going to, king isn't on it. I'm going to say, this is just my example. Prime number, probability of not a prime number. So the prime numbers, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I'm not saying this is the one you have to do, but the prime numbers are 2, 3, 5, 7, 11. So that would be 5 from 12. Not a prime number would be 1, 4, 6, 8, 9, 10, 12. So it's now This is an ideal answer. Why is it an ideal answer? Because I've written the prime probability events correctly. I've shown the probability, but I've also shown that I understand what I've done. I've listed those numbers out. All right? That would be an ideal answer for something along these lines. Now, it could be, you could have done something simpler, like the probability of a 6 is 1 from 12. The probability of 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, or you could have said not 6, would equal 11 from 12. Equally, that's fine. All right, no problem with that. So, events that have the same relationship as the one you discovered between column 1 and 2 are called complementary events. Write down the definition of complementary events. Well, I was hoping what we'd get to is complementary events, okay, are events where all possible outcomes are listed or covered or included or whatever you want for that word. Yeah? So two complementary events means that all possible outcomes are included. Now, I did see a couple of these ones. Probability of less than 7 is 6 from 12, yeah? And the probability of greater than 7 is 6 from 12. Now, that's incorrect. Why? What numbers are less than 7? 1, 2,
Says.
4.
So all of them.
So 6 from 12? Good. What numbers are greater than 7? 8, 9, 10, 12. 5 and 12. They are not complementary events. Why? Go on. 7's not included.
Wait, but why is 7 included?
It's not.
It's only 6.
Now I can add something in. I can either put a line under there to put 7 there. Or if I wanted it to be 6 from 12, I'd have to include the 7 in that one. The and equal to line. The and equal to. So this sign means greater than. This is greater than and equal to. So a couple of people used one where, sorry, the number in the middle wasn't included. Therefore it was wrong. But back to it. Complementary events are numbers that include all possible outcomes. And finally, what does it say? Write down as well as a rule involving their probabilities. So the probability, okay, of complementary events always adds up to
The same number.
1. Always. Why? Because it's 12 out of 12, or it's 52 out of 52, or it's 8 out of 8, or it's 6 out of 6. Oh no, I thought you were grimacing. Alright? Got it? It always adds up to 1 as a fraction, right? Or 100%. Because if you consider all possible outcomes, the probability that one of them will happen is 100%. Yeah? Now, I did see someone give me an example, right, for this next one. Right? Verify your rule with 2 examples. Now, someone wrote this, and I want you to tell me why. We don't need to know who it was.
No, that's theoretical.
Not. Wrong one.
Oh,
What are they? Experimental. They are suggesting with this possible answer that 1 in every 2 days is sunny, and 1 in every 2 days is
not
raining. Yeah, not so. Okay. That's like saying half our days are sunny and half are not. Is that true? Especially not in Bermuda. I don't know anywhere in the world where half your days are sunny and half your days are raining. Exactly half. Now, as Mackenzie's saying, there is no theoretical probability for that. There's only experimental probability. You'd actually have to look at the records, wouldn't you, and say, over a year, out of 365 days, Bermuda has 258 sunny days. So this could be 258 out of 365. This would have then been the rest, maybe. This was not a good example. Good examples are probability of
getting
a king or a queen or something like that. Yeah?
yeah.
That would be 1 from 30. Probability of not a king is 12 from 13. Verifying it all. 1 from 13 plus 12 from 13 is 13 from 13, which equals 1. Someone did a very nice drawing of a spinner. And they put 1, 2, 3, 4, 5, 6, and went on a spinner, the probability of a 6 is, or probability of an even number is, that's good as well. Could be anything. Now, explain why your rule works. This is why people struggle. Works because if you consider all possible outcomes, one of them must happen. Therefore, the probability is always going to be 1. Yeah? Guys, you are. Does that make sense? And that's it. Explain why your rule works. Complementary events. Struggling to pay attention. Not the only one. But explain why your rule works. Am I? Explain why the rule works then? What have I just said? One of them must happen. That's the whole point. Now, this is a big thing in probability. If you consider all possible outcomes, one of them is going to happen. So, for instance, if I said to you, I am going to pick someone from the class at random, what is the probability that I will get a boy? What is the probability I get a boy or a girl? 1. I don't need to count how many. What's the probability I get a boy or a girl? 1, because I've considered. What are the complementary events? Getting a boy, getting a girl. Okay?
Oh, even.
Yes.
Yeah.
Told you. Alright. So,
In this story.
currently, there's 4 girls and there's 4. Now, ladies and gentlemen. Well, let me just tell you what I'm going to do, so when you get back, you can get on with it very, very quickly. I asked you at the beginning to write down. You are now in your notebook going to summarise everything we've just done with example, explaining what it is, explaining the most important bit. Doesn't need to be huge, but it needs to include everything. So it must. What are complementary events? What's important about them? Give me a couple of examples. Ready? Good. Just to finish this off, gentlemen, we haven't got too long left. We haven't got time to do what I want to do. But, to finish this off, a complementary event. So, complementary events are, hopefully you've read 2 events that consider all possible outcomes. That should be outcomes, events is the vocabulary you're using. When you add the probabilities of complementary events, they always add up to 1 or 100%. Because why? There is nothing else that could happen. And then you should have an example. The easiest examples are get a 6,
Or
not get a 6. Yeah, that word not is very useful. Getting a king, not a king. Getting a red, not getting a red. Getting a heart, not getting a heart. It being raining, it not being raining. But that's a yes. Then you are talking over me. It's talking over me. Right. Who thinks they're quite confident with what they wrote in their test? I'm going to ask you now. Do you remember yesterday we did the rolling the dice? Probabilities.
Yeah.
Can I just ask you now to, in your book, do you still have your tallies there? Have you still got all those numbers written?
Yep.
Okay. So I am going to ask for that tomorrow. Tomorrow's lesson will be up to okay? What? That's right. We've got enough data. When we write them down, you are going to write them down. And then we will talk about what's happening. The most important bit about experimental is tomorrow's lesson. Good.